Hello everyone, welcome to my video on server-side programming. I'm going to have to touch on several concepts here, so hopefully I can be thorough enough to explain its core advantages. So here we see a simple diagram of a client-side relationship. This is client-side programming. Users can access their requested website on a variety of devices, operating systems, and/or browsers. The user opens a browser and creates an HTML request. The HTML browser then sends the HTML request in the form of a GET command. The HTML requests use similar syntax to JSON data as we learned in last week's material. The format is a web server name followed by the language, in this case PHP, and then a variable pair in the form of a query string. The first pair being the name and the second being the value. There can be multiple query strings in a single HTML request, probably as many as the HTML field will hold. It's quite a few. The web server then receives and processes the HTML request. After reading in the request, it locates the files that the user requested. These files are usually contained within the web server itself or a network-attached storage device. This is very similar to how GitHub works for our repositories that we upload our websites to. The web server then returns the requested files to the browser that initiated the request. Since we've been working with them all semester, we will readily recognize those files to be HTML documents, associated CSS style sheets, images, and possibly some JavaScript functions. The browser in the device then loads the HTML document, renders the CSS, and the local hardware performs the JavaScript functions. Here we see a screenshot of my weather gallery from a couple of weeks ago. From this screenshot, we can see that the client-side programming model works very well. We can see the images that were sent to my browser from the GitHub repository server. My browser has indeed rendered the CSS, and even though it's at the bottom of the page, and you can't see it down there, my JavaScript clock is running and has the correct dynamically updated time. So by examining this process, it becomes evident, and we realize the limitations of the client-side server model. The largest being the fact that everyone visiting this page will see exactly the same data, whether it's relevant to them or not. If you lived in a state other than Idaho, or even outside of the United States, this data would not be relevant to you. In this model, multiple pages would need to be created to provide the user with a more customized experience. For instance, a page could be created for just the larger cities in the country, or a separate page could be created for each of the 50 United States, or an even more inefficient scale, a page could be created for every single user who accesses this site. In this model, we can see that web servers would quickly be overrun by these individual websites. So how would the client-side model affect our internet user experience today? Let's kind of examine this for a minute. Netflix might still exist, but users might have to all watch the same movie at the same time. If you logged on while a movie was already in progress and streaming, you may have missed the first half, since none of the other millions of users would want to start it over for you. Obviously, Spotify or Pandora would not be able to create a different web page with a unique URL for each song in their vast catalog. And Pinterest might only be able to host a handful of pages. This would cause the pin you posted just a few seconds ago to be immediately overwritten by a user submitting their content right after. Before server-side programming existed, if you wanted to host a home video on the internet, this is from my day back in the 90s, you had to upload your enormous AVI or MPEG-2 file to a host, and users who wished to view your video then had to click a text HTML link on your website, which would redirect them to another site, and then the entire multi-megabyte video would have to be downloaded to their PC. Over slower DSL and dial-up connections, the download could take an entire weekend to complete. A user would have to wait for the download to finish before he could start watching it, and the dreaded, if your download got interrupted, you had to start all over again. Nowadays, server-side programming allows multiple users to connect to a single website like YouTube and stream billions of bytes of individual content to millions of devices all at the same time. So let's take a second and take a look how it works. So here we have a diagram of a server-side programming model. This is a very simple one. They're actually much more complex than this. But for simplicity, I just kind of put this one together so we can walk through how the process functions. Much like client-side programming, the user still initiates an HTML request from a browser. The web server then examines the request to evaluate where the request will need to be forwarded. In most cases, the request is sent to an application server. This could be an API server, this could be an Apache server, this could be an AWS server in the cloud. Even Microsoft still has a few Azure, even though they're not as popular as the others for this type of service. But their primary function is to construct dynamic page data to return to the web server. This type of server can also perform tasks like authentication to verify your account, make sure that you are authorized to be there, and they can even process PHP or ASP requests right within their own framework. The application server then looks up referenced data in a database server. This can be where cookies in your browser are read in to create a dynamic website, or even more customized based on the previous visits to the site. If you've been here before, it will remember, or using data from your browser indicating the sites you have previously visited. Data can also be appended here to include data that the user submitted on a form. So a good example of this would be like if you entered an ancestor name into a family history website. The application server would append it to the database server. The database server then returns the relevant data from your search to the application server. This is how sites like Amazon or Walmart provide only the data you request rather than giving you a list of their entire inventory. For example, a search for golf balls would only return items relevant to golf rather than the entire sporting goods section. Once the application server has processed the information retrieved from the database server, it is then able to build the dynamic website that it will return to the web server. In the case of a shopping cart, like Amazon, this is the point where other items the site calculates will be relevant to you may be added. For example, you may see a section that says, buy it again, and items you've purchased before are shown in there, or items you may be interested in are presented here. Some sites, they may make recommendations based on your internet region or your device type, or even produce advertisements based on websites you were at previously and then landed on their site. Once the site is constructed, it is sent back to the web server. The web server will then request static data from a file server. Static data would include style sheets, JavaScript functions, and HTML data. This is where the template is stored that will be displayed to you once you get the data back. So even though the application server may change the site dynamically and the database server returns different queries and different data sets, the file server is responsible for making sure every single site sent back looks the same, it's consistent, has the same styling, etc. Then the static information is returned to the web server. At this point, scripts may be calculated and other frameworks may be applied. An example of this would be session management, such as a bank website. This is going to be where they time your session, so it could time out after you've been on it for a certain amount of time. like taking a test, or if you have been idle for a certain amount of time, it will log you out. Session management would occur at this point in the process. By calculating math or other JavaScript functions on the server side rather than the client-side resource overhead is reduced, allowing the site to load more quickly and securely. After the framework and static data are applied, the HTML request is returned to the browser. So that the data that comes back is specific, it's secure, and it's optimized for your device and or your browser. So to sum up, the advantages of server-side programming are going to include the fact that scripting doesn't require plugins. This helps prevent overloading. Overloading causes slow load times, high CPU usage, consumes large amounts of bandwidth, all the things that we've been learning to avoid when we construct our websites. We don't want to use up people's bandwidth or freeze their computer using up all of their CPU overhead. It has a broader feature set. You have access to large databases that can't be contained just in one data server. You can have them spread out over several servers, several data centers. JavaScripts don't need to be parsed and interpreted for each page, meaning that they can be loaded once and then they can be passed off to other applications or other pages. Sophisticated graphic display logic can be displayed on less powerful devices. This is important because if you have, like a game, for instance, it can be rendered on a cell phone that doesn't have anywhere near the graphic processing power that a PC would have. Client-side programming can still be utilized to provide lighter tasks. So even though you have server-side programming, you can still use the client-side programming to do things like pull-down menus, pop-ups, or you can even add additional CSS styling to make the site more efficient and friendly. So I'm out of time. I could go on forever. This is a rather large concept, but hopefully I've given you an idea of what server-side programming is and what it can do, and hopefully this covers our subject. So thanks for watching. Everybody have a good week.